Welcome back to another episode of Agentic AI, the future of intelligent systems. I'm your host, Navveen Balani. And in this episode, I want to talk about something that has become almost synonymous with the economics of artificial intelligence tokens. Today, when we compare AI models, we often start with the same questions. How many tokens does the model consume? What does a million tokens cost? Which model is cheaper? How much can we reduce our inference bill? These are useful questions. Tokens give us a practical way to measure and price AI consumption. But as we move into agentic I think we are reaching the limits of what tokens can tell us. Because tokens measure what AI consumes. They don't measure what AI accomplishes. And they certainly don't measure the value of what AI accomplishes. That distinction becomes much more important when AI moves from generating responses to actually performing work. Think about getting into a taxi. You tell the driver where you want to go. The driver takes a wrong turn, realizes the mistake, turns around, takes another wrong turn, and eventually gets you to your destination. The meter has been running the entire time. Technically, the meter worked perfectly. It measured the distance and time consumed by the journey. But as the passenger, you probably have a different perspective. You care about reaching the destination efficiently. Something remarkably similar happens with AI. You ask a question and get an answer that isn't quite right. You refine the prompt and try again. You add more context. You ask the model to reconsider. Perhaps you try another model. Eventually, you get something useful. Every attempt consumed tokens. Every attempt used compute. And every attempt appeared on the meter. The meter isn't broken. AI providers incur real cost whenever computation happens. Models execute, infrastructure is occupied, GPUs consume electricity, and resources are used whether the final answer is useful or not. So, tokens are a perfectly reasonable way to meter resource consumption. The problem begins when we confuse that resource meter with a value meter. Knowing that an AI system consumed 10,000 tokens tells me something about its consumption. It tells me almost nothing about whether the task succeeded, and it tells me even less about whether the result created value. This becomes particularly important with agentic AI. A traditional AI interaction might involve one prompt followed by one response. An agent can behave very differently. You give an agent a goal, it reasons about the task, it retrieves information, it calls a tool, it observes the result, it might call another model, it might delegate part of the task to another agent. Something may fail, so it retries. It may retrieve more context, change its plan, call another tool, and continue until it reaches an outcome. To the user, that can still look like one task. To the infrastructure, it can be an entire chain of computation. And the meter runs through every step. Now imagine two agents completing exactly the same business task. The first agent consumes 10,000 tokens and completes the task successfully. The second consumes 50,000 tokens, makes several tool calls, retries 3 times, and eventually reaches exactly the same outcome. If we look only at consumption, the second agent used 5 times as many tokens. But the more interesting question isn't simply why it cost more. The interesting question is why it required 5 times as much work to reach the same destination. Maybe it retrieved too much context. Maybe it chose the wrong model. Maybe its tools were unreliable. Maybe the agent was allowed to reason for too long. Maybe the orchestration architecture created unnecessary loops. Now we are no longer discussing the price of tokens. We are discussing the efficiency with which intelligence produces an outcome. And this is where I think the economics of agentic AI needs to evolve. We need to move from tokens to outcomes to value. Tokens tell us what intelligence consumed. Outcomes tell us what intelligence accomplished. Value tells us why that accomplishment mattered. Consider a customer service agent. One system consumes 5,000 tokens and successfully resolves a customer's issue. Another consumes only 2,000 tokens but fails to resolve the issue, transfers the customer to a human, and requires the process to continue elsewhere. If we measure tokens alone, the second system looks more efficient. If we measure successful outcomes, the picture changes completely. Now consider a coding agent. One agent consumes 100,000 tokens but produces code that passes the test and can be merged. Another consumes 40,000 tokens but produces code that requires several rounds of human correction. Which one is actually more efficient? Again, the token count cannot answer that question. And now take the idea one step further. Imagine an enterprise procurement agent that consumes $5 of AI resources but identifies a purchasing decision that saves the organization $50,000. At that point, optimizing the workflow to save another dollar of inference cost may not be the most important objective. The conversation has moved beyond cost per token. It has moved to value delivered. This gives us three different layers of AI economics. At the first layer, we have resource efficiency. How many tokens, how much compute, how much energy, and how much infrastructure did the system consume? We still need these measurements. They tell us what the system required. At the second layer, we have outcome efficiency. How much of that resource consumption resulted in successful work? Now we can begin measuring things like cost per successful task, compute per successful outcome, retries per completion, or the proportion of computation spent on failed paths. And at the third layer, we have value efficiency. What value did those successful outcomes actually create? That value might be revenue generated, customer issues resolved, developer time saved, fraud prevented, risk reduced, decisions improved, or any other meaningful business result. The progression is important. Tokens measure consumption, outcomes measure accomplishment, value measures impact. And once we look at agentic AI this way, some of our assumptions about efficiency begin to change. The cheapest model is not necessarily the most economical model. The agent that uses the fewest tokens is not necessarily the most efficient agent. And the workflow with the lowest inference bill is not necessarily the workflow creating the greatest return. The metric needs to match the objective. If we want to understand resource consumption, measure tokens, and compute, if we want to understand whether agents are performing useful work, measure successful outcomes, and if we want to understand whether agentic AI is creating business impact, measure the value of those outcomes relative to the resources required to produce them. There is also another dimension to this. The financial meter is not the only meter running. Every unnecessary inference requires computation. Computation requires electricity. Depending on the infrastructure and location, that computation can also carry carbon, water, and hardware impacts. A failed reasoning loop, therefore, isn't only a financial inefficiency, it can also be an environmental inefficiency. But this reinforces why simply minimizing tokens is not enough. Imagine one agent uses half as many tokens but fails twice as often. Once retries and failed attempts are included, it may consume more resources per successful outcome than the apparently more expensive agent. The denominator matters. Instead of asking only how much energy an AI system consumed, we should also ask how much useful work was produced from those resources. This is where economic efficiency and environmental efficiency begin to align. Both benefit when we eliminate work that does not contribute to the outcome. And that has direct implications for how we design agentic AI systems. We can choose the smallest model capable of reliably completing a task. We can avoid sending context that the model doesn't need. We can improve tool call reliability. We can prevent repetitive reasoning loops. We can set boundaries on retries. We can route different tasks to different models. And we can stop computation when additional reasoning is no longer improving the probability of success. But perhaps most importantly, we need to change what we observe. Imagine an enterprise dashboard telling you that your agents consumed 10 billion tokens last month. You know your consumption. You probably know your bill. But do you know how many tasks those agents actually completed successfully? Do you know how many required retries? Do you know how much computation was spent on failed paths? Do you know the cost per successful outcome? And where the outcome can be quantified, do you know how much value those successful outcomes created? Those are the measurements that begin to turn agentic AI from an API consumption problem into a business system. Tokens are still useful. We will continue to need them. We will continue to measure compute, latency, energy, and other resource metrics because they tell us what the system consumed. But the unit of consumption cannot become our definition of value. An organization doesn't ultimately want a billion tokens. It doesn't want a million model calls. And it doesn't want 10,000 agent executions. It wants customer issues resolved, code shipped, fraud prevented, revenue created, risk reduced, decisions improved, and work completed. That is why I believe the next stage of agentic AI economics needs to move from tokens to outcomes to value. Measure the resources consumed. Measure whether those resources produced a successful outcome. Then measure whether that outcome created meaningful value. When we connect all three, we can finally answer a much more important question than how cheap our tokens are. We can ask how efficiently we are converting computation into intelligence, intelligence into outcomes, and outcomes into value. That is the metric that will matter as agentic AI moves from experimentation into the core of the enterprise. The goal isn't simply to consume fewer tokens, the goal is to make the computation we consume count. Because ultimately, the value of agentic AI will not be measured by how much intelligence we purchased. It will be measured by what that intelligence accomplished. I'm Navveen Balani, and this has been Agentic AI, the future of intelligent systems.